Today your lesson is over factoring. So we're going to start with some basic numbers, finding greatest common factor of just numbers or constants, and then moving up into polynomials with variables and exponents. With this video, you are free to pause it at any time you want, rewind it to look over concepts that may not have made sense the first time around. You can move ahead if there's things you know how to do. So that's the advantage of this video format. Please take advantage of it how you see best. So greatest common factor, okay, GCF. So kind of answer the question here. It stands for greatest common factor. You probably learned this skill or were taught this skill back in elementary school. There are a couple ways you can do it. The GCF of 36 and 42, we can list out all the factors of each. That gets a little bit tedious, especially with bigger numbers, but we'll show that. So for 36, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36 as factors. And 42, we've got 1, 2, 3, 6, 7, 14, 21, and finally 42. So if we look through the list and find the greatest one they have in common, and we will see that the biggest number is 6. So the greatest common factor of 36 and 42 is 6. The other way we can do this that I really like, we can use kind of an inverted box method. So we'll take 9 and 24, okay, for the next one. And what I do, I'm going to make a little factor box. I'm going to put both 9 and 24 inside here. And I think of the greatest common factor of each, and I put it off to the side. Well, I know that 3 goes into each of these. So 3 times 3 is 9. Put that other factor down there. 3 times 8 is 24. Put the 8 under there. And now I check to see if 8 and 3 have any common factors, which they do not. So in this case, 3 is the greatest common factor of 9 and 24. So the variables, not much different. We just throw the variable in. So we look at each term separately. So start with the constants, 2 and 6. The greatest common factor that they share is 2. And we look at 6x and 2x. Well, look at the x terms. They each have one x in them. So they each have 2, they each have x. 2x is the greatest common factor there. And then for x squared, x to the 5th, what we could do, we could list them out. X squared is x times x. X to the 5th is x times x times x times x and times x a 5th time. They each have 2 x's in them. Okay? So right there. So they each have x to the 2nd power. That's your greatest common factor of those two. All right, so now moving on into binomials. Today we're going to factor 8x squared plus 10x using our GCF method. So we're going to start by finding the factors individually of 8x squared and 10x. So for 8x squared, well, we've got 1, 2, 4, and 8 for the constant. And then we have x squared, or x to the 2nd power, for that one. For 10x, we've got 1, 2, 5, and 10 for our constant. And then we have 1x for the x. So we see what they have in common. So they each have a 2 in them. And they each have at least 1x. I guess I should have written this out separately. I should have x times x. They each have one of those. So 2x is the greatest common factor. Now think about what's left over. So if we were to take 2x, okay, out of 8x squared, well, we're left with 4x. And if we take 2x out of 10x, I should probably erase that, we're left with 5. So using the greatest common factor, we've kind of reversed what we did last unit. Okay, we take out the common factor, and what is left is 4x plus 5. Easy to check, just distribute the 2x back through, and we should get that original problem. So 2x times 4x is 8x squared. 2x plus times 5 is 10. And that's where we started. So that is our solution. So we're going to go ahead and factor these two problems. Now here's where if you want to pause the video and try it on your own, you can. And if you want to stay with me for this, you can. So 30x cubed minus 12x squared. Well, greatest common factor between 30 and 12, they each have a 6 in them. And then between the x cubed and x squared, they each have x squared. If I take 6x squared away from 30x cubed, I'm left with 5x. And 6x squared out of 12x squared, I'm left with 2. There's our solution. If you want to go back and check it, feel free. Multiply the 6x squared through, and you'll get where we started off. Now for a trinomial, 5y to the 5th minus 10y squared plus 20y to the 4th. They each have a 5 in them as a factor. They each have y squared as a factor. So take 5y squared out of the first one, we're left with y cubed. 5y squared away from 10y squared, we're left with 2. 5y squared away from 20y to the 4th, we are left with 4y squared. Always good practice to get our polynomials in the proper degree order. So in the parentheses, I'm just going to rearrange them so the terms go in descending exponents. Okay, and we'll keep going. If you haven't paused the video yet and tried them on your own, you definitely should now. So 30x plus 12x squared, that looks very familiar from the last one. Just maybe the exponents are a little bit different. So we pull 6x out of each. We've got 5 for our first term, and then 2x is left second. Again, I like to get them in proper order of degrees. And that should work out. And no, the next one. Well, 7 and 5, there are no common factors. However, the x's have common factors. So we take an x away from each term. That is what we're left with. Okay, now we have multiple variables in our polynomials. Same process, just adding a variable. So if the first one, 15ab squared minus 25abc, well, we see a common constant factor of 5, and they each have an a, and they each have at least one b in their factors, in their terms, and only one has a c, so it's not common. So from the first term, 5ab is taken out. We're left with 3b. And from the second term, we're left with a 5. The a and b are gone. And 5c. There's that one. Again, if you're still not sure about this, multiply them through, distribute, test them out, like we did last unit, and that'll be a good way of checking. Okay, multivariable trinomial over here. Same process. So 18, 12, and 6, the constants have a common factor of 6. They each have at least one x in them, and they each share a y. So the first term, we take 6xy out, we're left with 3 and one of the x's. The second term, we're left with 2. X is gone, but y is left. And the last term, well, it's all gone. 6xy matches up there. So we do plus 1. Okay, we've got to include that 1 there because that is part of the trinomial. Okay, moving on. Okay, now we're just going to find greatest common factor of those 3 terms. Okay, we're not factoring. We're just finding greatest common factor. So 12, 14, 18 start with constants, and they all share a 2. x cubed, x to the 6, and x to the x squared, they all have x squared. That's as far as we can go. Same kind of problem. If you haven't done so already, go ahead and try to pause it. Find the greatest common factor here. They all have 3 for a factor. They all have at least 6 x's. And they all have at least 2 y's. And finally, okay, same kind of question. Now we are going to actually go through and factor it. Okay, not just find the greatest common. So 20, 30, and 40 constants all share a 10. A term, they all have at least a squared. B term, they're all at least b squared. Which leaves us with the first term. Take 10 a squared b squared out. We're left with 2 a cubed b. Second term, we're left with 3 and then 1 of the a's, but the b's are gone. And in the last term, we're left with 4. The a's are gone, but 1 of the b's is left. And that's as far as we can go. This concludes your lesson over factoring via the greatest common factor method.